Hi. I'd like to talk about black holes, as in black holes up in space. I find the topic really interesting. I'm not a mathematician or a scientist, so I can't really back anything I say up with any kind of formula or whatever. Um, but to be honest with you, I've seen a lot of scientists provide formulas, and then other scientists provide their own formulas which contradict those formulas. So I think the whole thing is still pretty open. Um, anyway, so basically my understanding of a black hole is really simple. Um, but you have to understand one thing, and that is that space itself is in fact made up of something. It's like a form of physical matter. Now, we can't understand or perceive this form of physical matter, because if we go up into space outside our Earth's atmosphere, we experience nothing. Um, to us, there's nothing there, nothing we can see, touch, feel, or measure. So, with any form of tool that we have. So, to us, space is already a vacuum. Okay, but that to me, it's sort of like taking a fish out of water. You can, the fish understands that it lives in something, but when you take it out the water, all of a sudden the fish thinks it's in nothing. All right, pretty much like we go out of our atmosphere and we think we're in nothing, but the fish has no concept that it is still surrounded by something, and that is the atmosphere, the air, or whatever. And the thing is, obviously, the fish the fish can't understand that it's still in something, because it can't measure it, it can't perceive it using any of its senses. And space is the same thing. We can't measure space with anything that we have. And I believe that a black hole is basically space that's been pushed out to form an empty vacuum inside space. Right, so if we imagine for a second that space is like a solid matter. Right, now to make it easy to visualize, imagine if you've ever seen like a movie about submarines, and they fire torpedoes at each other, and the torpedo explodes underwater, and what happens is it creates a bubble in the water, which then which expands, and then after the force of the explosion has all been expended, the water around it then forces it closed again, and then collapses. And to me, that is the same thing that's happening in space. Is that when the star explodes, it has such tremendous amount of force that it actually forces the space itself out, and then what you have is something that's less than space. Alright, so it's effectively a vacuum in space. And what happens is then space, once the force of the exploding star has been expended, space then slowly collapses in on itself again. Now the thing about it is, anything that's traveling through that space will then travel with the space as it collapses. Another important thing is when the star explodes and forces the space out, what you have around this bubble of space is the space around it is actually denser than normal space. So light that's traveling through that space might slow down, or even stop, or get diffracted, I don't know. But and basically light that's traveling directly into the black hole would, I would think that it would just stop on the edge of the black hole, and it would stay there and move along with the space as space is then collapsing in on the hole. All right, and so yeah, to imagine the effect of light, the effects on the light. Imagine a fish traveling through the water as this torpedo explodes in the water, right? And what happens is, as as the water expands, or as this bubble expands, the fish gets distorted along with the water, because the thing is, the water is the medium in which the fish exists and travels, so therefore it cannot escape, and it also gets distorted along with the water that is being pressurized outside this bubble. So that's the similar thing that happens with light. As the star explodes, the light around it gets, or the space around it gets denser, and then as the hole is then collapsing again, any light that's traveling through or around the black hole then gets trapped in that dense space around the black hole, and then is likely to get sucked in with the black hole as it collapses. Alright, so and light traveling directly into the black hole would probably stop, because space is the medium in which the light exists and travels, so therefore the light traveling directly towards the black hole would more than likely just stop on the edge of the black hole. The photons or whatever would accumulate around there, and then probably fall back in, and then as all those photons and light that are surrounding the black hole gradually get sucked into the middle of the hole as it's collapsing, when it reaches the point where it all comes together again, there's a tremendous amount of photons or energy that's stored in the middle.